All right, welcome back to Mr. PFs with Calculus, Unit 3, Day number 7. We are going to be differentiating inverse trig functions, more specifically only sine and tangent. I don't know why, but for whatever reason, AP Board has decided those are the only two that we really need to focus on inverses for, and you really just memorize them. All right, before we get into that, so let's actually just look at inverse sine and what it actually looks like. This is what it looks like. I know you don't do a whole lot with this in pre-calculus, but you should have seen this before. This actually does have endpoints, so the domain from left to right goes from -1 to +1, both included. So this is the furthest left, and this is the furthest right it ever gets. The range would be from everything from -π/2 all the way up to π/2, both included as well. All right, so that's all the piece is. It has endpoints on both sides. It does not go on forever. And that's what the inverse looks like. Because, I mean, it kind of makes sense because you're talking about the inverse. You can only have, because you're switching the x's and y's, and the heights can only be the same for, so that just means the x's can only be restricted to those numbers. Either way, all right, so derivative of an inverse function, inverse sine, and this is just a breakdown of why it is what it is. So remember, inverse just means switch x and y. So if you take y equals sine of x and you switch the x and y, and then you differentiate both sides using your implicit differentiation, derivative of x is 1, derivative of sine of y is cosine of y, dy dx, of course. And then you get dy dx by itself here, right? And then we remember that our trig identity, that sine squared of y plus cosine squared of y is equal to 1, right? And knowing that, so I'm going to then change this. Ooh. So I'm going to change cosine of y to cosine of y would be 1 minus sine squared of y. And then if you do square root of both sides, this is just, sort of a side, hey, I'm going to change this into this using this prior trig identity, which I now saw for cosine of y. Now, you would never normally memorize this, but I'm just trying to prove why the equation is what it is. Cosine of y is this, so I'm going to replace this with this, and there you have it. You have basically, that's the equation of the inverse, because we found the inverse first, and then we differentiate it, and this is what we ended up with. So this is really what you need to memorize. And I'll be honest, these two are the exact same thing, just one's with and without the chain rule being applied to this letter. So this is what you need to memorize right here. No, you do not get a formula sheet on the AP exam. So you will have to have memorized these. So inverse sine, derivative of inverse sine will be 1 over the square root of 1 minus the argument squared times the derivative of the argument. So it's the same thing up here. These are actually the exact same equations, just with or without. If this is just x, then you use this formula. But let's say this was like x squared. Then it would be x squared squared times the derivative of x squared, which would be 2x. And that's why this du dx gets put there. So if it's anything other than just an x, then yeah, you need to use this. But if you have this one memorized, then you're good to go. All right, so let's apply that to this equation. Find the derivative of y with respect to the appropriate variable. So if we want to find dy dx of the inverse of this, so dy dx equals 1 over the square root of 1 minus the argument. This is all the argument, 2 minus x squared, times the derivative of that argument, which would be, what would that be, -1. All right, so it looks like that's going to be, now you could clean that up to just this. I wouldn't take the steps to square this. It's really not worth it. Most likely on the multiple choice, this is what you're going to be given. But I guess if you see something a little bit different on the multiple choice, then you go ahead and evaluate this out and make this all one big term. But I would suggest not worrying about that. I would say most likely this is what you're going to see on the multiple choice. Now, this is just what the graph, if you put this into a graphing calculator, it's going to end up looking like this. This is the derivative. This is the derivative graph of this. Now, let's break it down, just see how that makes sense. Because if you put this in a calculator, you get this. It starts out by going down pretty significantly. So the derivative at the beginning is a pretty large negative. And then it gets closer and closer and closer to 0. This is actually doesn't get 0. It gets closer and closer to -1. That's a slope of -1. And then it's going to start getting lower and lower. It's going to start getting more negative because it's going down more. So yeah, it does kind of make sense. And it's only from 1 to 3 because that's what they gave us in here. Because that's all that x can be for that argument. All right, so now let's look at tangent of x. So let's go through the same steps for tangent of x. Then we'll do a couple of practice problems and we'll be done. All right, so this one, tangent of x, I believe goes forever. So our domain is all real numbers. And our range is anything from -pi/2 to pi/2. Because tangent does technically go forever on its domain. Inverse, so same steps. I'm not going to go through these again. I know that took quite a bit of time, but it's basically the same steps. Switch their x and y, differentiate both sides to find the inverse tangent, and you end up getting this as your equation. So this is what you need to memorize right here. The derivative of tangent inverse will be this. Now, for whatever reason, you are only expected to memorize tangent and sine. Sine has the square root on the bottom. Tangent does not. Otherwise, they look very similar. So what they'll do is they'll give you an answer sometimes, and you have to recognize, well, if they give me 1/1 plus x squared and it says square root, then that tells me right away this is an inverse sine. That's a derivative of an inverse sine. It's that square root on bottom that kind of gives it away, to be honest. Tangent does not have that square root on bottom, but pretty much everything else is the same, only it should be subtract. Tangent is add instead of subtract. All right, find the derivative of, okay, so dy dx equals 1 over, so it's going to be 1 plus the argument squared times the derivative of the arguments. And then you could, of course, clean that up just a little bit, but that's essentially all there is to it. So it's really not that difficult. 1 over 1 plus the argument squared times the derivative of the argument. I know there's no multiply sign there, but you kind of know that anytime there is no symbol, that means it's multiplication times the derivative squared. All right, and that's what this graph would look like if you put it into a graphing calculator. Of course, you can just put 3x squared on top, and you can break it down and analyze it the same way I just did the last one, but I would rather focus on a couple of problems. Here's 2 practice problems. So dy dx is 1 over, remember, we're finding the derivative of both sides. Derivative of y is dy dx. The derivative of this is 1 over square root of 1 minus the argument squared times the derivative of the argument. Okay, chain rule involved here. So the derivative of this, of e to the x, is always itself times the derivative of the chain again. It's triple chain here. Times 4 again. All right, so we've got 4e to the 4x over square root of 1 minus e to the power. To a power rule, you can just multiply them, you get 8x. To me, that looks like the cleanest, most simplified answer you could possibly have on multiple choice question, because that's most likely what this is going to be, but you never know. I guess it could be a free response question as well. All right, so dy dx, we're taking the derivative of both sides. It's going to be equal to 1 over 1 plus the argument squared times the derivative of that argument. And we can then just clean it up to x to the 6th power. And that's about as clean as it's going to get. All right. These are the other rules, just in case. If you wanted to memorize all the rules for all of them, but the only 2 you're going to have to memorize that I have been told are these 2. These are the only 2 that we've been instructed. Those are the only ones that they are going to give you on the AP exam. But if you want to take it a step further, or if you're taking Calculus BC, I think they might expect you to memorize them all, but not here, not in AB. All right, thanks again for watching, and I'll see you on the next video.